Myself, Minu Joske, Assistant Professor, Jyoti Engineering College, Cherthurthi. I am uploading this video as a part of online teaching learning process. Today, we are going to discuss a topic, Fourier integral. We will discuss some problems from the same topic, Fourier integral. Before coming to the topic, let us discuss the formula of Fourier sine and cosine integral. If the Fourier integral is having f of x is given to be an even function, then b of omega is equal to 0, then the Fourier integral reduces to Fourier cosine integral given by f of x is equal to integral 0 to infinity a of omega cos omega x d omega, where a of omega equal to 2 by pi integral 0 to infinity f of x cos omega x dx. Similarly, in the case of this Fourier integral, if f of x is given to be as an odd function, then a of omega becomes 0 and the formula reduces to Fourier sine integral, which is given by f of x is equal to integral 0 to infinity b of omega sine omega x d omega, where b of omega equal to 2 by pi integral 0 to infinity f of x sine omega x dx. Now the problem, the first question, find the Fourier cosine integral to show that integral 0 to infinity cos omega x by 1 plus omega square d omega is equal to pi by 2 e raised to minus x. So we need to prove the result by the Fourier cosine integral, which we have discussed in the previous slide, so that by the definition the Fourier cosine integral is given by f of x is equal to integral 0 to infinity a of omega cos omega x d omega, where a of omega equal to 2 by pi integral 0 to infinity f of x cos omega x dx. Now take the function f of x as pi by 2 e raised to minus x. Therefore, a of omega becomes 2 by pi. This f of x can be replaced by pi by 2 e raised to minus x into cos omega x into dx. Now this 2 by pi and pi by 2 can be cancelled. It becomes integral 0 to infinity e raised to minus x into cos omega x into dx, which reduces to 1 by 1 plus omega square. This formula has we have discussed in the previous classes. So that by Fourier cosine integral f of x is equal to integral 0 to infinity, this a of omega can be replaced by 1 by 1 plus omega square into cos omega x into d omega, so that this f of x becomes pi by 2 e raised to minus x, which is equal to integral 0 to infinity cos omega x by 1 plus omega square d omega, and which is the required result. Now the second question, express the function f of x is equal to x square 0 less than x less than 1 equal to 0 1 less than x less than infinity as a Fourier cosine integral. So again we are having the problem from the Fourier cosine integral. So write down the value of a of omega. A of omega is equal to 2 by pi integral 0 to infinity f of x cos omega x dx. Now substitute for this f of x. F of x is equal to x square, and this integral becomes, we are splitting this integral 0 to infinity into 2 depending upon the functional value. It will be from 0 to 1 plus from 1 to infinity, and from the integral 1 to infinity f of x can be taken as 0 and remains integral 0 to 1 x square cos omega x dx. Now we need to apply integration by parts to calculate this integral value. So that I take this x square as the first function and this cos omega x as the second function. Now by the rule, first function into integral of the second function integral of cos omega x, which is sine omega x by omega, minus, now this x square is the first function, sine omega x by omega is the second function, so that minus derivative of x square. Derivative of x square is 2x into integral of the second term, which is minus cos omega x by omega square. After the negative sign, the alternate sign plus. Now this 2x is the first function, minus cos omega x by omega square can be taken as a second function. So plus derivative of 2x, derivative is 2 into integral of this term, and which is minus sine omega x by omega cube within the limits 0 to 1. Now, when I apply the limit, I take this x is equal to 1 as the upper limit. This becomes 1 square into sine omega into 1, and which is sine omega minus the lower limit is given to be 0. So it is 0 into sine 0, which is equal to 0. So we are having sine omega minus 0 divided by omega. Now both the signs, negative signs, make this as a positive sign. So we are having plus 2 into upper limit is 1, so that 1 into cos omega into 1. So it is cos omega minus 0 into cos 0, which is 0. So we are having cos omega minus 0 divided by omega square. Now for the third term, plus into minus getting minus sign. So minus 2 into sine omega into 1, which is sine omega minus sine omega into 0, which is equal to sine 0 is 0. So it is sine omega minus 0 divided by omega cube. Now we will cancel the 0 terms. Rest we are having 2 by pi sine omega by omega plus 2 cos omega by omega square minus 2 sine omega by omega cube. Now take the LCM, so that LCM can be taken as omega cube. After taking the LCM, the term becomes 2 by pi omega square into sine omega plus 2 omega cos omega minus 2 sine omega divided by omega cube, and which is the Fourier cosine integral of the function f of x is equal to x square when 0 less than x less than 1, and equal to 0 1 less than x less than infinity. Thank you.